Two events E and F are called independent if whether or not one of them occurs doesn't affect the probability of the other event occurring. Formally, we write this as the probability of E vertical line F equals the probability of E, where the vertical line represents the word given. So this means that the probability of E happening, given that we know that F happens, is equal to the unconditional everyday probability of E when we don't know whether or not F happened. And similarly, the probability of F given E is equal to the probability of F. You only need to check one of these two equations. If one of them is true, then the other one will also be true, and we consider E and F to be independent. For example, let's suppose that we're rolling two fair six-sided dice, and event E is getting a 6 on the white die, and event F is getting a 6 on the black die. These events are independent. The unconditional probability of event F, that is, when we don't know anything about whether event E happened, that probability is 1/6. But when we know that E happened, we got a 6 on the white die, that doesn't tell us anything about whether or not we got a 6 on the black die, because they're two different dice. One can't affect the other. So the probability of F given E is also 1/6. Because these probabilities are the same, E and F are called independent. Now let's suppose that event E is still getting a 6 on the white die, but event F is the event that we get a sum of 12 on the two dice. These events are not independent. Here's why. When we roll two dice, we have 36 possible outcomes, and only one of them involves getting a sum of 12. That's when we have a 6 on both dice. So if the dice are fair, the probability of event F is 1 out of 36. But now let's think about the probability of F given E. Well, we know that we got a 6 on the white die, so we can eliminate all of the possibilities that don't involve that event happening. Now there are only 6 possible outcomes left, and they're all equally likely, assuming the dice are fair. So we still have one way to get a sum of 12, event F, but we only have 6 possible outcomes. So the probability of F given or conditional on event E is 1/6. Because 1/6 isn't the same as 1 over 36, we say that E and F are not independent. In real life, we often take independence as a reasonable assumption. For example, suppose we're doing a random survey, and event E is the event that the first driver that we sample has had a car accident in the past year. And event F is that the second driver sampled has had a car accident in the past year. If we're taking a random sample from a large population, then there's no particular reason to suspect that the two drivers live nearby each other and might have crashed into each other. There's no real reason to think that event E happening would affect the probability of event F. So we assume that E and F are independent as long as this was a random sample from a large population. The multiplication rule for independent events says that if two events, E and F, are independent, then the probability of E and F is the probability of E times the probability of F. Let's see how we can use this to solve a problem. According to an article on Forbes.com, 5.959% of American drivers have had car accidents in the past year. If we sample 2 American drivers at random, what's the probability that they've both had car accidents in the past year? We want to find the probability that they've both had accidents, which we can rewrite as the probability that the first driver has had an accident and the second driver has had an accident. We have the word "and" in that statement, which is a good indication that we might want to try using the multiplication rule. Let's let event E be the event that the first driver has had an accident, and event F be that the second driver has had a car accident. So that means that the probability that they've both had accidents is the probability of E and F. We're doing random sampling from a large population, all American drivers, so it's reasonable to assume that E and F are independent. That means we can use the multiplication rule for independent events. So the probability that both drivers have had accidents is the probability of E times the probability of F. The problem tells us that 5.59% of American drivers have had car accidents in the past year. That means that the probability that the first driver has had an accident is 0.0559, just taking the 5.59% and dividing it by 100 to turn it into a decimal. And similarly for the probability of F. That means that the probability that both drivers have had accidents in the past year is 0.0559 times 0.0559, or about 0.003.